All right, welcome to this recorded video lesson of the Geometry Big Ideas section of 1.4 Parameter and Area in the Coordinate Plane. So hopefully by the end of this video tutorial, you will be able to classify polygons and find the perimeter and area of polygons that are within a coordinate plane or an XY graph. So one major core concept is to talk about what a polygon is and some characteristics that it has. So a polygon is a closed plane figure formed by 3 or more line segments. And an easier way to describe those line segments are sides. So this polygon example down below points to a couple different key points. So a side BC, for example, is the line segment that connects the 2 points B and C. And then another name that we're going to start calling our points is a vertex. Notice how underneath the polygon is labeled by using all of the letters that encompass the points and the vertices. Classifying polygons. These are ways that you can name the different types of shapes depending on how many sides make up that polygon. Hopefully you are at least somewhat familiar already with maybe the shapes up to 6 for triangle, quadrilateral, pentagon, and hexagon. But beyond that, maybe these words are new to you, and a lot of them come from Latin prefixes, oct for 8, non for 9, deca for 10, and anything that you don't know what it is, we're going to call an n-gon. So keep this chart handy and be able to reference back to it as we're naming our shapes. Okay, so classifying each polygon by the number of sides and determining whether it's convex or concave. So first, let's take a look at how to determine just based on the number of sides. So this first quadrilateral A, you are going to count all of the sides of that shape, and hopefully you can clearly tell that it has 4 sides. So you would call that a quadrilateral because that is the name earlier from the chart to determine that it has 4 sides. Now, to figure out if a shape is convex or concave, I want you to imagine drawing an infinite line overlapping the line segments that make up that shape. So notice this red diagram right here has an infinite line through that shape. And because that line is crossing another line segment at a different part down here at the bottom left-hand area of this quadrilateral. Because it crosses, it is considered concave. Now for the second one, same thing. It has 6 sides, so referencing back to our chart, this is going to be called a hexagon. So now we're going to do the same thing, and we're going to notice that it doesn't cross any of the sides going through the other portion of the infinite lines. So this type of polygon is convex. So concave is if it crosses any of the other sides or it has an indentation, and convex is if any infinite line overlapping a line segment does not cross anything else. Okay, next example is looking more onto a coordinate grid. So looking at the perimeter of a triangle ABC that has the points -2, 3, 3, -3, and -2, -3. So one easy first step is to draw this triangle on a coordinate plane and plot all of those points, connecting the line segments between all 3 of those. Remember, your first number in a coordinate graph is your x-coordinate, and then your second one is the y. So go ahead and connect all of those line segments. And then you're going to find the length of each one of these sides of the triangle. Side AB, we're going to need to be able to use our distance formula, or if you feel more comfortable using Pythagorean's theorem, because this triangle is a right triangle specifically. So you're going to plug in your x1 and y1 coordinates for your A, and then your x2, y2 coordinates for your B, in the spaces within your distance formula. So instead of x2, we are now using the b coordinate of 3 minus the -2. The minus always stays, and you're bringing the negative that comes from your coordinate grid. Go ahead and simplify that all the way down. 3 minus -2 becomes a 5. and then combining the negative 3's to get you negative 6. Then you're going to go ahead and square those numbers. 5 squared is 25, and negative 6 squared is 36. Add them together to get 61, and you're going to roughly estimate that square root of 61 to get 7.81. So that is the length of side AB. Now the directions say to find the length of each side and find the perimeter. So we're going to need to continue on for side BC. Because this is a completely horizontal line, they share the same y-coordinate, so you can just find the distance between your x-coordinates. You take the difference between them, and then the absolute value is just the distance. Or if you're looking at your coordinate grid, you can just count 1, 2, 3, 4, 5 to get you all the way from B to C. Doing the same thing to find side AC or CA, it doesn't matter the order. Again, this is a completely vertical line, so you can just find the difference between your y-coordinates going from 3 down to negative 3, or you can just count to get to 6. Now these three numbers, your side AB of 7.81 plus your 5 plus your 6, add all of them together for a grand total of a perimeter of 18.81. So depending on what type of shape it is, you will need to find all of the side lengths and then add them together for your perimeter. Okay, now doing the same thing for area. Again, we're looking at a triangle. So we're going to go ahead and plot this triangle. And when you plot all of those points, notice that D, E, and F are as follows on the grid. 1, 3, 4, negative 3, and negative 4, negative 3. Connect the dots, draw your line segments. Then you're going to need to find the length of its base and its perpendicular height. Well, luckily on a coordinate grid, we're already given a horizontal line segment as its base for EF. So we are going to use the length of EF as our base. So finding the distance between negative 4, negative 3, and 4, negative 3. They both share the same y-coordinate, so you just count from negative 4 to positive 4 or subtract and you get 8 as the length of your base. Now remember, when looking at the height, it must be a straight horizontal or a completely perpendicular to your base. So on this grid, the red line that appears is going to be your height. And again, just by counting your grid lines, you can determine that the height of this triangle is 6 units. Now if we remember, the formula for the area of our triangle is 1/2 base times height, or base times height divided by 2 is another way to remember it. So you would take your 8 times your 6 times 1/2, or divide by 2, and get 24. Now because this is a coordinate grid, you don't know if these are feet, inches, miles, so these are just 24 square units.